calculating that rotational inertia is something that you'll do in a calculus-based class. It's pretty easy to recognize why you might need calculus because you have mass that's located at multiple radii. But simplest of terms, if we were thinking non-calculus and maybe we had our rotational object here again, and we wanted to calculate the rotational inertia for this guy, maybe about the green axis versus about the orange axis. The rotational inertia, the moment of inertia, can be calculated as just the sum of all of the masses times the radii, the radius of those masses squared. So for example, I have my thing here. Zoop, 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 zoop. Okay, so let's say that it's rotating about that green axis. So I'm looking like this, right? And I have these four masses, and let's say that all the orange masses are the same as the yellow masses. So I have 1, 2, 3, 4 masses, and it's rotating about this axis. I can calculate my rotational inertia by just taking mass 1 times the radius 1 squared plus mass 2 times the radius of 2 squared plus mass 3 times the radius of 3 squared and plus mass 4 times the radius of 4 squared. If they all have the same mass, then this turns into, if they all have the same mass and they all have the same distance from that axis of rotation, then this just easily turns into 4mr squared. So the rotation of a point mass, just one mass about some distance, is mr squared. Because we have 1, 2, 3, 4, we get 4mr squared. So instead of rotating it around that long green axis, if I chose to rotate it around one of the other axes, such as this yellow one, the rotational inertia, or the moment of inertia of this object, will change because my green dots are further away from my axis of rotation than my orange were. And so if I'm rotating it like this, we can again take the sum of our masses times the radii to find the rotational inertia of this same object about a different axis. You can do that at home if you want to. This idea that different objects have different rotational inertias about different axes can be seen with a pencil. So if you take your pencil and you rotate it about just the long axis and you just twist it like this, it's pretty easy to twist. But if you took that same pencil and you were to wiggle it between your fingers, it gets a little bit harder to turn. Same pencil and you try to rotate it about the end, it gets even more difficult to turn when you rotate it about the end. So big takeaway, the same object can have different rotational inertia based on the axis of rotation that you have chosen or that it's rotating about. The other big takeaway from this is that the rotational inertia of a point mass is just mr squared. We can use that later when we're dealing with angular momentum.